For this vocabulary notes video, you are going to need your IC67, which is on page 61 of your geometry spiral. If you don't have that, as well as something to write with, go ahead and pause the video, grab your materials, and come back. Please make sure you're filling this in so that you can bring it to class tomorrow to use when we do examples and practice. All right, we are talking about surface area again today. Right cylinders and spheres are the focus this time. So two shapes today instead of only one. Surface area, remember, is the total area of all of the faces of the shape. So when we're thinking about a sphere, everything is really one face, one big surface. When we're thinking about a cylinder, there are three, the top and the bottom, and then kind of like the around the outside edge. If you think about it like a soup can, it would be like the label part, and then the top of the can and the bottom of the can. So for a cylinder, our surface area formula is going to involve that label around the outside, which can be found by doing 2 pi r times capital H plus two bases, but kind of like with cones, those bases are always circles. So instead of calling it 2 capital B, we're just going to go ahead and plug in that formula for a circle, and it's going to look like 2 pi r squared. The surface area of a sphere is going to be different because there aren't bases when it comes to a sphere. All we really have in a sphere is a radius, so the official formula for surface area of a sphere is 4 pi r squared. R is the radius of the sphere. In a sphere, the radius is going to start at the middle and it can travel out to any point on the sphere. So usually we draw it out to the edge directly left or right, but we could draw it straight up, we could draw it out to the front. Those clearly don't look like they're the same length, but that's because we're trying to draw a three-dimensional shape on a two-dimensional sheet of paper. So even though they look different, that radius is consistent whether we draw it out to the right, kind of out to the front, whether we draw it straight down to the bottom. All of those would be radii that match. In a cylinder, it's going to be part of the base, and so that radius will go from the center of the circle out to the edge. Capital H still stands for height. That height is the distance between the bases. So a sphere won't have a height because it doesn't have bases, but a cylinder will have a height in between those two circular faces. So that will be the capital H. I've kind of said this a couple of times, but this version right here of a solid is our sphere. Just kind of looks like a basketball or a ping pong ball. And then the soup can over here is what we call a cylinder. They want us to identify the required measurements for calculating surface area. So for the sphere, we're done. We just need a radius. And so we've drawn that in actually a couple of different places. Also for the cylinder, we're done. We need a radius and a capital H height, and then a radius again. So we have both of those marked. All right, that's it for today. Bring those notes back with you and we will jump into some examples.